is Chapter 2, which deals with inequalities, and very similar to Chapter 1 in the sense of you're solving for a variable. And there's going to be one-step, two-step, multi-step, and then we will also introduce absolute values with inequalities. So this is section 2.2. We are going to focus on adding and subtracting in order to isolate the variable. So very much like an equation, when we see my variable w, we ask what's happening to w. Well, 6 is being added to it, so we do the inverse of adding 6, which is subtracting 6 from both sides. And that leaves us with w is less than or equal to -4. And now we want to graph our solutions. And when we see w is less than or equal to, so things that we have to remember is that when we have less than or equal to or greater than or equal to, we're going to have a closed circle, which means it's including the boundary, and I always call it the boundary. And then when you have greater than or less than, we give an open circle, which means not including. So since we have an equal sign, we will be including this boundary, and it says my solutions or the solutions. That's why we always want the variable first. The solutions are less than or equal to. You don't have to write this, I'm just writing it out. Less than or equal to -4. So what does that look like? Well, here's my number line. I'm going to show where 0 is. I'm going to show where my boundary, which is -4. So this is going to separate true values and false values. One side will be true values, one side will be false values. The true values are considered the solutions. The false side is called, they're not solutions. So I have a closed circle because I can include -4. -4 is less than or equal to -4, and then my solutions are less than. So values that are less than -4 go to the left. So notice I only have two things on my graph, 0 and my solution or my boundary. I have my graph, which is above the number line. It's not on top of the number line, it's above it, and you can read it nice and clearly. Now we will hustle along and do these relatively quickly. We do the inverse, which leaves us with m is greater than -3. This time, notice we don't have the equal sign, so we do 0. I do my border, and then it is going to be an open circle, and I want my solutions are greater than -3. So that would go this way. And so if I plugged in any point where it's on the side of the solution, it would come out true. That's why I say the true side and the false side. And this time, the border is not a solution, so we do not include the border. Oh, this is a good one. Couple of reasons this is a good one. 0 is less than s. So this is where I would advise students to rewrite it. Using the variable first, we see that my inequality is eating the variable. So when I rewrite it with the variable first, it's still eating it. And now I can graph it a little bit more confidently. I know that how I read it, my solutions are greater than 0. Open circle, going to the right. If we look in this way and we see it, we see 0 is less than s. Some students sometimes make a mistake and think that it's going less than to the left, but it doesn't say that. My solutions should actually, my variable should come first. It's a little bit easier doing it in that way. -8 less than or equal to x. I'm going to rewrite that as x is greater than or equal to -8. I'm going to take my graph, show where 0 is, show where -8 is. It's going to be a closed circle and going to the right. We have to read the directions. It says to solve and then graph. That's why we know this is a good one. A lot of students make a mistake here because we have double signs. I'm going to simplify the double signs. We know that two negatives make a positive. So I rewrite, instead of writing two signs, I write one sign representing those two signs. I don't write plus negative, I just write plus. Two negatives make a positive, and now I'm going to isolate by subtracting 3. P is greater than 7. 0, 7, open circle, going to the right. I'm going to simplify. I keep talking to you when we have our little conferences. You're noticing that I'm looking at your work and I'm telling you, hey, before you start moving variables on either side of the inequality, always see if we can simplify either of the sides. And that just saves us work. Positive 6, negative 5 makes positive 1. Now we're going to subtract 1 from both sides. Q is greater than 3. 0, 3, open circle, going to the right. My variables, my numbers on my number line are below the number line. I see students writing it up on the top. We don't write it up on the top. They always go below. Notice the tick marks, and notice that my graph is not on top of the tick marks. My numbers are not on top of the tick marks. Everything's nice, clear, concise, spread out. I can read it. We're going to simplify first. Now we're going to move the move the constants, and t is greater than 6. Move this number line up a little bit. 0, 6, open circle, going to the right. Everything looks good there. Just checking. We're going to simplify. We can combine like terms. 5a minus 4a is a. Add 2. 5 is less than or equal to a, which can be written as a is greater than or equal to 5. 0, 5, closed circle, going to the right. A lot of graphs going to the right today. Oh, lots of crazy stuff. So first thing I'm going to do is I'm going to combine these two signs. We have double signs. Plus a negative is minus 9c plus 10c, and is less than, and we're going to write it 6. We can simplify this. Now we're going to combine these variables. 22 plus c is less than 6. We'll subtract 22. C is less than negative 16. 0, negative 16, open circle, going to the left. I like this. So this is a good skill that you should be practicing. It says a number plus 10 is less than 34. So when we have this phrase, let's use this, is less than, we know that that is an inequality. Is leads us to believe that it's an equal sign, but then is less than turns it into an inequality. So a number, it's a variable, plus 10 is less than 34. And then solve the inequality. We don't have to graph it, we just have to solve it and make sure. So I would look for this statement if this was on a quiz, and then I would look for the solution. A number minus 8 is at least. Ooh, so now we have to decipher is at least. A number minus 8 is at least. That means the smallest it can be is 14. That means it has to be greater than or equal to is at least. So it can be equal to 14, but it has to be more than it. Its smallest value is 14, and then it must be greater than or equal to 14. We'll add 8 to both sides. N is greater than or equal to 22. We don't have to graph it, just solve it. the sum of a number and 7, so n plus 7 is less than 15. That's nice and easy. Minus 7, n is less than, what's that, 8? Easy. 9 is less than or equal to, so is less than or equal to, so 9 is less than or equal to the difference of a number and 1. The difference is subtraction. So we get 9 is less than or equal to n minus 1. We will add 1 to both sides. And we get 10 is less than or equal to n. These are nice. So that's a really good task. That's a good practice problems to get very proficient at. Make sure that you are familiar with the different verbiage and the different phrases to translate. You order a new pair of running shoes from a website that offers free shipping on orders of $75 or more. Your shoe costs $69.95. Write and solve an inequality that represents how much more you must spend to get free shipping. So we'd say, well, let's actually purchase. We'll say P. How much more do you have to purchase plus $69.95 must be greater than or equal to 75. So it can be or more. So it can be equal to 75 or more. So how much more do I have to purchase along with my above and beyond my $69.95 to be more than or equal to 75? Right, and solve. So now we have to solve it. 69.95. 69.95. Let's add 2 zeros there. P is greater than or equal to. We have to borrow. That's 5. That's 0. That's a 9. Got to borrow. 9 from 14 is 5. So we have to purchase at least $5.05 more to get free shipping. The cost of shipping your shoes is $7.79. Should you purchase a package of socks that costs $7.50 in order to get free shipping? Explain. All right. So the cost of shipping your shoes is $7.79. That's if I don't get to that $75. So should you purchase a package of socks at $7.50, meaning I would get free shipping. So if I do $69.95 plus $7.50, or remember, I go back here, I need to, right? I'm $5 away from my cost. So, whoops, sorry, went the wrong way. So if I add socks to it, that's 5, that's 4, carry the 1, that's 7, carry the 1. That's going to cost me $77.45, but I don't have to. That's with socks. This is with socks. So with socks, I get shoes and socks for $77.45. If I don't get the socks, I have to pay $7.79. So that's 4, carry 7, carry 7, carry. So if I just buy the shoes alone, oops, sorry, that's not 5, sorry, that's 7. So if I buy just the shoes, so this is shoes and shipping, I'm going to have to pay $77.74. If I get the shoes and socks, I am above the $75, so I get free shipping. So notice it's less than just the shoes alone. So in the fact that I buy the socks, not only is it cheaper total, but I also get the free shipping. So it says, should you purchase a package of socks? Yes, I should add socks for a lower total cost. That's kind of cool. So I get shoes and socks cheaper than just shoes alone. Oh, baby. Yes, the purchasing things that you need to do. In exercise 15 and 16, write and solve an inequality to find the possible values of x. So the perimeter is less than 37.8. So perimeter is going to be the sum of the distance. So when we see p is less than 37.8, well, perimeter is going to be x plus 11.8 plus 12.5 must be less than 37.8. So we'll add those together. That's 13. That's 24.3 is less than 37.8. Well, minus 24.3 minus 24.3. X is less than, that's 5, that's 3, and that's 1. So x needs to be less than 13.5. So find the possible values of x. X must be less than 13.5 meters. Good? Makes sense, right? Same thing, the perimeter of this object, P, can be less than or equal to 24.1. The perimeter is going to be 6.4 plus 6.8 plus x plus 7.9 must be less than or equal to 24.1. Let's add those together. That's 12. That's 13.2 plus x plus 7.9 must be less than or equal to 24.1. Let's add these two. That's 11. That's 1. That's 2. Plus my x must be less than 24.1. Let's minus the 21.1. And x must be less than or equal to 3 centimeters. So this side length, if it's going to be less than, if the perimeter is going to be less than 24.1 centimeters, then my missing side must be 3 centimeters or less. Write and graph an inequality that represents the numbers that are not solutions of each inequality. So let's look and solve. Let's see what the solutions for x are. So my solutions are, and we'll do this solutions in green. So let's move this up a little bit. So 0, -3. So my solutions are less than or equal to 3. So these are all the true values. But it wants to know what are not solutions of the inequality. So if we were going to graph the points that are not, or the numbers that are not, we would have to have an open circle at -3 and then greater than. So the red would be an inequality. So now I would have to write an inequality. X, my solutions cannot be greater than -3. That's if we saw this graph, how could I write that? X is greater than, notice it doesn't have an equal sign because it's open. So the inequality that represents the numbers that are not the solution are x is greater than -3. Really good question. I like this. This is a really good conceptual problem. X is greater than -0.5. So you got to do some real good thinking here. -0.5. Notice I didn't write it super close. I wrote it out here so it didn't interfere. If these are my solutions, it's going to be an open circle greater than. So the ones that are not the solutions would be a solid and going less than. And if I had to write an inequality for that, that looks like x is less than or equal to -0.5. Really, really good. I love those two problems. Those are really good conceptual. Got to think about it. Make sure that you understand what they're trying to say. All right, that was a nice, gentle, good practice. Hopefully you're doing these before the assessment. Next week, I think it's Thursday, we're taking our assessment. And make sure that you can be very familiar with these problems. Have a good one.